I guess one of the most common soil types that we have in San Diego County are what's called a DG, or decomposed granite type of a soil, and that tends to be a really coarse, gravelly soil that's degraded from granite boulders that it makes up a big part of our county. And that decomposed granite soil, or often they call it DG, they just call that it across the board. It tends to be really low in organic material, so it drains. It's almost like a really coarse sand. It is full of all kinds of minerals that are, so it's a mineral-rich soil, but at the same time it's incredibly porous, and water moves through it really quick. It dries up. It tends to be, if you've got erosion, it tends to really move fast with erosion, and you lose it from like high velocity of water. So that's one of the downsides to it. At the same time, it's not that it's a bad soil, it's just different, and it's definitely one of the main ways to help amend it and improve it and turn it into usable soil for productive crops is organic matter. It's like you really want to go right off the bat real heavy with compost, and it doesn't have to be super high quality compost, because the main thing is you're trying to fill a lot of those pore spaces with organic material. So that helps fill the pore spaces, helps to now start to create an environment for the soil microbial life, and now you're going to have them starting to inhabit that soil. They have the opportunity to, because without the organic matter, they just plain old don't have a home. It won't retain moisture, and also that organic matter will act as their kind of main food source. So it'll slowly start breaking down, and as they're inhabiting that soil, they're going to be exuding their biological glues that they put out into the soil. And those exudates, they're called, they tend to actually act as like a glue for the soil. They will hold the soil, the whole structure together. So it's not just roots holding soil together, but it's really the entire food web that exudes things and that hold the soil together. So that's a good start, to just start to add compost, and it could be, like I said, low quality compost, but that's a start, especially if you've got a really coarse decomposed granite, and it's really really high in just like mineral material, and it doesn't have any percentage of other particle sizes, or it doesn't have a lot of any beginning percentage of organic matter, then just kind of really going heavy on compost is a really good idea. Marginal soil, which is common with decomposed granite soils, they're really nutrient poor, not good structure. It doesn't hold together. It doesn't really support a lot of diverse plants. The key is to really get heavy on the organic matter, and then grow in it, and also adding some organic fertility. So that's one thing that people tend to hold back on, and they don't really get started right off the bat with some type of organic fertilizer. The plant material that's been growing there has adapted to grow there, but it doesn't really exude a lot of carbon in the soil. It's still pretty poor. Doesn't have a lot of biology in it, but the biology that's needed for those native plants is there, but not really for grapes or orchards or diverse vegetable production. So that's what makes that's where our work as like a horticulturist or farmer comes in. We've got to understand what these domestic crops need, and it's a lot more than our native plants. Now, like a soil in the middle would be what you'd think of as a loam. It could be a sandy loam, and here at Wild Willow, that's what's here. It's this soil that's been, over thousands of years, slowly deposited. It's along a riverbank, and for eons, it's been depositing minerals, organic matter that's flowing from foothills far away, nutrients that just come year after year after year, and this kind of big alluvial plain that's been just deposited here. It's several feet thick, and it's a kind of a medium dark sandy loam. There's absolutely no clay in the soil whatsoever. There is some silt, and silt is just basically really pulverized mineral. So it's like kind of like sand particles, but just pulverized down to like talcum powder. So there's silt in the soil. Silt tends to fill the pore spaces, and silt can move real easy. But if you've got a good balance of organic matter and biology in the soil, it tends to hold together really well. And this land has probably been farmed for 100 years by a number of different people. And there's a lot of organic matter here, a lot of biology in the soil. If you just add water, things do well here. It's easy to open up the soil if you add water. Without it, it's a little compacted, but not terrible. And we try to only work this soil and plant it and open the soil up when there's proper moisture condition. So that will help preserve the structure of the soil. If it's too dry, it powderizes and it can blow away or wash away. If it's too wet, you literally know, no matter how careful you are, it'll tend to like vibrate and compact the soil, and you'll lose the you'll damage the structure of the soil. So we try to kind of get it moist and then plant and or amend it. But this would be considered a sandy loam. A couple things that we've learned over the years is that we'll plant, instead of one row of something down a bed, you plant two, and you get a little bit better, quicker canopy over the bed, and you don't have as much exposure from the sun on the bed, so you get less evaporation off the soil surface. There'll be times where it's better to, instead of 2 rows of beans, you put 3 rows of beans, and you put them just far enough apart. You play with that spacing, so you're going to get this quick canopy. So you get cooler soil, less evaporation. The plants literally are happier, even though it seems like they're crowded. But there's so many other factors that are affected by that, and you have less salt, because that little bit of canopy that covers, you'll have much less evaporation off the soil surface. So we've been able to just do tiny little adjustments and tweaks and address that very quickly. I was a little bit leery when I first started to see some salt buildup. I thought I didn't have enough experience to deal with that, but just a few little steps and really took care of it quickly. But this type of soil is not as common in our county as others. You'll find some areas that either we're in grain production or dairy production. A lot of the very flat surfaces that are along, that are in river valleys, or might be along riparian areas, or where there used to be oak woodland, and where oaks may have been removed and it's a flat, low-lying area. There'll be really good loamy soil there, partly from some deposits from rivers, but also from what the trees provided for hundreds and hundreds of years. They just kept building up soil from their roots and all their associations with the microbes in the soil, and all the leaves that just kept building, and the other plants that were in those habitats. And so we'll have some of those soils around the county too, and those are prime soils for growing, especially if they're doing it properly, where you're going to focus on not just extracting from that soil, but you're going to focus on doing high quality regenerative farming practices, where you're really kind of the big focus, and people are understanding that we just need to just really get lots and lots of carbon in the soil and sequester carbon, and not have the soil covered as throughout the year as much as possible, so it's covered with living plants and healthy plants, and not really holding off on using chemical inputs. The organic practices, all these ecological services that all these microbes do and the plants do, that's all totally doable in farming. Real often we just take some of those services and we say, no, we'll do that ourselves. We'll add fertilizer, or we'll add organic matter, or we'll add nutrition, or we'll add a pest control when normally, you know, if a really good balanced ecosystem, they're going to buffer all these things and they're going to keep things in check. But when we focus on one thing and we do it poorly, we're just extracting the nutrients and extracting the carbon and not allowing that carbon to build back up, along with just the whole biological network is so reduced that now there's not enough fertility just naturally built in the soil because those things aren't there anymore. And the controlling pests and disease, those organisms that used to give us those free services, now we've kind of ignored them, and so that's a big part of this movement. A lot of these practices work really well on small scale, you know, 1 acre, 2 acre, quarter acre, but they are just starting to find ways that they can use these kind of practices where there's a lot of organic matter put back in the soil, and there's a lot less tillage and a lot more, the residues of the crops are just left in place. There's a lot of that starting. They're figuring out ways that they can do that on a larger scale too, even with equipment. And they're doing a lot of rolling and crimping and different multi-species cover crops. So it definitely, it looks different than what we're doing on a small scale when it's all handcrafted farming methods, where we're doing mostly everything by hand, or we're using really small specialized equipment on you know, small scale. But they're making big steps and advances to doing really high quality conscious changes in large scale ag, where they're finding that there's a number of things that fit into their practices, that they're just kind of slightly changing. They were doing cover cropping. Instead of just doing one species, they're doing, you know, 20. And instead of disking it all under, they're just crimping it down. So there are some ways to scale up this type of farming, and but they're kind of finding these other models that are fitting into sequestering carbon.